secondary pump will pick up the slack, and you will get an alarm back at the front end. This is running based off of a DP balancer set point, which is 15 pounds. And you'll see that's the difference between your supply and your return. And then you have your, actually it says right here, so right now, we're running based off a runtime, which is at 200 hours. So every 200 hours that this pump sees that it's running, then it's going to switch to the next one. You can do a manual rotation method, and we also have this pump kick function. So I was told that the water here, it's got a lot of sediment in it, and it can get set up inside these pumps if they're not, moved weekly or monthly. So what we've put in is a pump kick. So now throughout the summertime, as the heat exchanger is not running, you can click this and it'll actually circulate all of the hot water pumps that are in the building for, I believe it's a 10-second period, just to make sure that they rotate. And you see this.
Is that automatic or is that manual?
It's manual at the moment. So that's where we have our pump kick button.
Can we put a time clock in there?
I believe we can. Yep.
Schedule.
So now you have your run conditions. So it shows that the system's run based on requests. You've got no requests at the moment, but then it also comes on if your outside air temp is below 60 degrees, below 45 degrees. Run the hot water system continuously. If you feel that some of these functions are working, you can play with that button, or you can disable the hot water system if you are working on it and you don't want it to run. And then this tells you what the state that it's currently in. Same thing, you've got your outside air and humidity, and then some other alarms, which is your high and low hot water supply, and then your high and low differential pressure. And I believe that will be all for the graphics presentation. Do we want to go for a walk now and see where the equipment's actually working?
The train unit uses this heat exchanger for hot
Yes.
water?
Yep. So from where the demising wall is back, all of the equipment uses the heat exchanger for hot water, I believe. You ready to go for a walk? So we can, oh, there we go. So these are the drives for the pumps. You can see your two pumps in here. Oh, yeah, you've actually got a handoff auto for your start command on these. So if you're out here and you need to run these or run one of them and it's not coming on, so as opposed to throwing this, you can actually engage the rib relay that's here, and that will energize one of the drives. That'll give it the start.
They don't have all of those.
I believe they do. Most drives have those. Yeah, but that I'm not certain of.
Why did they change the code?
Okay.
This is a What do you think that's like?
They were easy enough to work with.
I mean, they're like fairly.
Yeah, the documentation on them was simple enough to find out where the points to land were.
What's the standards? We've never seen a fall.
Pinnacle startup guys seem to get them all programmed pretty easily. So, I would say for having seen them for the first time and to get them up and running pretty well, that
You seen these opened
it's
up?
nice enough drive to work.
Have you seen them opened up?
The controller for this is
You
here.
open up
It's
so
a
you
power
what's the
supply.
stuff exposed?
So for some reason, you guys aren't getting any lights on these cards, which is really important to see. The electricians were nice enough to label what the breaker is, but just in case, you actually have, these are little breakers on top, so these may trip in case you do get an overload, and then you've got your switches to see what's turned on and what's not turned on, what's on, what's off. Yep. Yeah, and I highlighted the points inside that we landed on. So, yep, so there's the page, and then we highlighted the points, what we had landed on. So if you find, say, a wire comes loose or something, you guys need to hook it back up.
Yeah, or we want to swap the drive, something like that. Okay.
And next, we're going to get the card with a selector switch for the air handling units for a high, medium, and low speed. So if they need to quiet them down or they want to get a little more airflow, the selector switch is actually going to be mounted right before the door. I'll show you as we leave. It's where that's going to be located. Your 1/3, 2/3 valve are right above you. So you've got your 1/3 and your 2/3 respectively, I believe. You've got a pressure and a temp sensor and a pressure and a temp sensor. So this gives you, your supply and your return, and this is where it's registering its differential from. I believe that that's it for this space. They've already, which is nice, they opened up the space where the old heat exchanger used to be, so now that's all in line.
Mike, can you explain it, Mark? I know you have it with you, but can you explain what the three?
That's what she wants to know.
No, I'm not sure.
The three-position switch for the air handling units is going to be right here.
Okay.
So it's just going to be a high, medium, low,
Okay.
depending on what you want to do. So if they're too loud, you can switch it to low. If you need more air, switch it to high. If you want to be somewhere in the middle, you can do medium. So it's going to be located right there, and I'll label which position is where.
That's for,
It's tamper-proof, that's why.
that's for the air handlers? You can override everything?
Yeah,
I think that's available, but there will be,
I explained to her. The coaches complain that they can't be heard, but of course,
so
now we
it'll
have the lights
primarily be a high
buzzing.
and low.
It's
So
quieter.
if it's too
So
loud,
maybe something that we don't touch, but we just want to have the flexibility to make an adjustment. Also, during like a special event or something, if there's a speaker, sometimes they want,
Graduation.
right, they want to reduce the noise, so.
Yeah, we used to just shut them off.
The VAV box for the spinning room is up by the air handling unit. So this room and then the rooms in the mezzanine, all those air handling units are actually upstairs in the attic on either side of the AHU 10. So a little bit nicer to get to than having to put a 12-foot ladder in the space and you climb up and get to it. Thermostat's located right in the room on the right over here.
Because you got space.
You don't want to show everyone that space right now. They're going to see. Yeah, you can.
Yes, it's a 2-degree. Yeah, 2-degree, yeah.
Oh, yeah, don't say.
So now we're going to walk to, do we have a key so we can get in?
Yes.
This through these double doors right here?
I don't even. Right, except that we have, we used to sit at the basketball games and have our coats on. I don't want to do that.
So if everybody wants to come in here, I can show you the D-Strat fan controls.
See the clips that moved in?
I didn't do it.
So Chris, can I talk to you for a second?
So here we have the cards for the D-Strat fan controls, and this is the macro air controller. So this takes the Yasukawa Dry-Speak Modbus. There's a Protonode controller in here. It's a field server device that translates into BACnet, which is what we see through our AMR. And this is how we communicate back and forth. And we're actually able to read what the frequency is of those fans, as well as write to them what the frequency we want it to be at. And it is, as we said earlier, it is an individual control. So if you want to say shut one off, you have that ability. Unfortunately, that ability will only be through software. So they will have to get in touch with you, Billy, to ask you to do it, unless there's a computer on the premises and somehow we set something up for them. But as of right now, the way it stands, everything comes out of
So you
here.
got one controller for each fan.
Nope. These two. So this would be the upper thermostat, feeds in
Okay.
here. This would be your lower thermostat,
Yeah.
and then this is for your communication. So this is actually the BACnet communication to the fans themselves through the 3 Yasukawa drives.
Okay.
These are the power supplies for both. Jim from JME was nice enough so that we have them labeled. So this actually feeds out the power supply for the 3 VAVs. The VAV for each room, each meeting room down here, is actually in the space itself. And then this feeds this panel.
What's the secondary on those?
24 volts?
24?
Yep, so it's 120 and 24. So we'll just pass through into this space. I mean, I know that we need to go in every one. The ceiling was marked for the VAV boxes. So it doesn't look like the ceiling has been marked for the VAV boxes are, so you will have to refer to the plans for exactly where they are, or just the old-fashioned way, pop some ceiling tiles, and you'll find out where it is. So now we're gonna head upstairs. Sorry.
Oh, yeah, you're right.
Discharge air temp, unfortunately, it's somewhere behind here, so you're gonna have a bit of a fun time trying to get to that. But the controllers face out, so you'll be able to access all the components, pull the cover off, you can see the damper shaft, and you know, the lights that blink in the controller. Why don't we head upstairs and take a look at HU10?
Right, the sensor that's on the wall here.
Yeah. So,
Here, all this.
yeah, so this is the CO2 sensor for this whole area, and then this is a common thermostat for the VAV boxes up there. Much nicer.
The CO2 sensor, you can mark the backdrop.
It's HU10, it feeds the mezzanine and it feeds the rooms, as well as the spinning room, which are directly below us. The field house itself has 4 air handler units separate from this that work to maintain that space. You've got your drives, which is you've got your supply fan, and then you've got your return fan drives located over here. Well, this is actually the return fan cabinet. This is your supply fan cabinet. This is the controller for the unit itself. You've got this is your duct static sensor, where the probe for it is actually punched into the ductwork over here. Nothing real fancy to look at, it's just a pneumatic tube that they strung out across the ductwork and punched it in. It monitors that versus ambient air. These are your safety relays. And then this is your board. What's nice about the ME cards is that you actually have handoff auto switches here. So as you get more comfortable with equipment and know what output you're looking for, you can actually cycle stuff on there. These are your transformers for the equipment. So this shows your 3 VAVs on the mezzanine, which you've got 2 on that side and then 1 right over here. That's VAV 11. And then the balcony VAV and the electrical room's the end card. So the electrical room, which is 1 floor below us, all the way down the other end. As I said, it's just a thermostat that monitors that space. And then the balcony VAV, which is the VAV in the access hatch downstairs. This is the transformer that feeds our panel. So the same thing, you've got your on-off switches for your outputs coming out, and then you've got your resettable switches, overloads right here. So in case you do have some sort of fall, you do your first check here to make sure you got lights and to see what's going on.
There aren't any fire dampers in this place.
No, there are not any fire dampers. But you do have your duct smoke.
This is right, one controller and then there's another one there in operation.
For
Duct smokes.
your supply fan CFM. So this is looking at velocity pressure, and then through a calculation we're changing it to what you're actually reading in your CFMs. And it's the same thing for the return fan. And you've got a return fan humidity, a return air temp. You've got your thermostat, which is wrapped around the coil, which you can see right here. So it's on the discharge side of your hot water coil. And I believe that this is your chill water coil. So the same thing, your filter DP, which you see in each side of the filter. So, as your filter starts to get clogged, it picks up the pressure on the inlet side of it, decreasing the pressure on the outlet side of it, causing this to increase. And then you've got a mixed air temp, which is another capillary temp, which is wound through behind these filters. As we had said earlier, we've got 3 you've got a 3 damper compartment. So your center one, which is an open-closed damper, that's set for your 2,500 minimum CFM outside air coming in. And then the other 2 are modulating for your economizer position.
Is that freeze manual reset?
No, nope. So
You can do that from the central, as we call it?
yeah, so it's an automatic reset, but it does need to be reset through software.
Yep.
So you will actually physically have to go into the software, and as I showed you the button that's on
Yeah.
the graphics page,
Yeah.
hit that, and you can reset it.
How
So-
about the, well, maybe you get to that point, the refrigeration of the air conditioning part of it?
So that's, we can actually see that on the other
That's
side.
on the other side,
Yeah,
okay.
yeah, we'll see where the solenoid is and all that fun stuff. Temps to watch. This is the start-stop relay for your pump. So the same thing, you can actually shut that off right here. You can close it so you can turn it on manually, or you can leave it in auto, which I suggest. And then you've got the on-off switch for it. And the same thing, you've got your valve in the end, that's a hot water valve to tell you how much is coming in and out. And then you've got your bypass that just allows it to circulate water through for freeze protection. And then this is your chill water coil. Your DX coil hasn't been started up yet, but here's your solenoid. The command from this comes outside the unit, so we send an enable through software to the unit itself, and then that decides when it needs to come on and off, and that's what it cycles the solenoid.
So the brains is that the unit, the outdoor unit?
Yep.
Okay.
Yep.
And heaven forbid, if that hot water coil there cracks, is there a drain?
Inside there's a drain pan for here. I don't know that it spans the full length. We can pop the cover. We'll open the door and see.
Do you know that or
if it's
no?
there.
Or for condensate, in case it get, is there a drain inside there for both coils?
We'll
No?
look inside there, but I'm not sure if it catches the heating coil as well.
We didn't say no, we just didn't know.
That I don't know, I didn't pipe it, I'm not sure where.
So if we want to turn around, we can see 3 of our VAV boxes. Feed the spaces. One of these is for your spinning room. The other 2 are for your mezzanines, I believe A and B. And like I said, the balcony's downstairs. And then another mezzanine was the one that we passed on the way in. Each one of the VAV boxes has its own flow station, so it can actually measure the amount of air going into each room. So it's kind of nice. You can see whether or not you're actually getting flow, whether or not the air handling unit is putting out what it's supposed to. You know, that's all based off of. So if for some reason you find out you're not getting any flow, maybe the damper's closed, maybe the air handling unit's off. Both of those things you can actually visually see through software. And if you can't tell through that, then obviously you got to do the old-fashioned method. Come up and measure. Your reheat coils have their own valves on them. Perpendicular to the coil like this is off. If it's parallel with the coil itself and the piping, that means that it's fully open. And these do modulate, so anywhere in between, obviously, it's a percentage of water flow to the box itself. You know, based off of what the space temp is, that'll determine what percentage of water, hot water, that it wants to move into the space.
They look like the balloon ones.
Yes, yeah. I believe all the bright orange valves are actuators. So, I guess at this point, does anyone have any questions? Nobody? Everybody feels pretty comfortable?